Good afternoon. So today I'm going to talk about new localized ventilation for high quality indoor climate and energy saving. So poor indoor air quality is mainly caused, as you know, by inadequate ventilation and also release of contaminants. A recent study has reported that, in fact, occupants perceive air quality decreases more when the room air is polluted with biofuels emitted from our bodies compared to the air polluted with orally exhaled biofuels. The study, in fact, was done by a student of Professor Tanaben Pavel. The human body emits various gaseous compounds, such as volatile organic compounds, sulfur compounds, ammonia gas. Some of those can cause high irritation, headache, eye irritation, etc. Also, the human body emits bioaerosols, which constitute viruses and bacteria attached to our skin flakes. And then further, if they're infectious, they can cause infection among the occupants. So ventilation is important in order to dilute or remove these contaminants. We can divide the ventilation strategies in two main groups. Total volume ventilation, which we all know, the main principle is to ventilate the entire space, which is, of course, inefficient, since we need to supply high amounts of air in order to dilute the contaminants in an acceptable level. Also, by the time the clean air reaches the occupants, in fact, it is already polluted with the contaminants in the room. Also, the occupants have limited control to adjust the ventilation system in a way that it meets their thermal comfort preferences. Localized ventilations, they're more efficient in terms of providing clean air directly to the breathing zone. Also, the occupants, personalized ventilation, for example, the occupants have control over the supply flow rate and temperature, and they can adjust it as they wish. However, one disadvantage of this way of supply air is that, in fact, when the pollution is coming from our body, then it will prevent the occupant who is using the personalized ventilation, but it cannot guarantee that this pollution won't spread in the room and cause cross-contamination. So the most efficient way, in fact, is to remove the pollution at the source. And therefore, furniture-integrated localized exhaust ventilation can be implemented, for example, in places, in situations where occupants are seated for a long time or recovering in healthcare facilities in beds. I developed and studied bed-integrated ventilation method, so-called ventilated mattress. And the idea of this method is that it has a local exhaust implemented on the surface of the mattress, which sucks small amount of air that is able to capture and exhaust pollutants from the body. And then either it can locally first, this polluted air can be cleaned and then recirculated back into the room, or it can be connected to the main background ventilation of the room. So I performed a series of experiments. Don't worry, these are not real people. These are mannequins. This is a thermal mannequin lying on the ventilated mattress, and also called here polluting patients, since biofuels simulated with tracer gases were released from its body. And then there is another patient in the room, and this heated dummy here represents a doctor examining our patient. So I perform experiments at 1.5 exchange rate, 3 and 6, which are the recommended by the standards ventilation rates for hospital patient rooms. And the mattress was operating only at 1.5 liters, combined with mixing ventilation at 1.5. So here are some of the results. You can see the average concentration of pollution emitted from dark pits of the mannequin, and then it was measured at the mouth of the occupants. As you can see, when the mattress is working only at 1.5 is exhausting air with background mixing ventilation, 1.5 exchange rate, in fact, reduces completely the pollution, and it's much more efficient than supplying 4 times more air into the room. So I also performed some energy simulations in order to see if the method has potential for energy savings. These are results from energy simulations done for double patient hospital room located in Copenhagen. The room was ventilated with mixing ventilation at different flow rates. The mattress was, when the mattress was operating, the room was ventilated at 3 exchange rate. And then you can see, in fact, that compared to 6 exchange rate recommended again by the standards for hospitals, it's using the mattress, it's 52% more efficient, and then 27 respectively. And also further energy savings can be achieved if radiant panels installed on the ceiling are used combined with the mattress, and further then the background ventilation can be reduced. Another method which has the same operation as the ventilated mattress is the so-called ventilated seat cushion, designed for people who spend a lot of time seated. The cushion has small openings along its surface, which again the air is sucked close to the body, and it can be either exhausted out of the room or recirculated using some cleaning method inside. The method was found to be efficient as well, reduces almost to minimum the body pollution. Also, it was found that when we exhaust only 3 liters combined with mixing ventilation at 1 exchange rate, it provides the same concentration of pollutants as ventilating the room at 6 times more air. Also, energy simulations were performed, and it was found that it has huge potential. I haven't included this because of time limitation, but those of the methods were tested in terms of thermal comfort, and we found out that they will be beneficial, especially in climates, hot and humid climates. They provide cooling of the body, which can be useful. Yeah. Thank you.